Welcome to part 6 of our Link G4x mini training tutorial series here. We're going to be taking a look in this tutorial at setting up our basic inputs for our Link G4x. So this is going to be including our map pressure sensor, our throttle position sensor, engine coolant temperature, and intake air temp. We need to make sure that these are all calibrated properly and set up properly so that when you fire up your engine, you're going to have things working as expected. We're going to go through how to calibrate things and just making sure that everything's in order when you are about to fire up your engine. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with calibrating our basic sensor inputs to our Link G4x box using our PC Link software. Now, what are our basic sensor inputs? This is going to be things like our throttle position, our map sensor, engine coolant temp sensor, and intake air temp sensor. These all play a role in delivering the proper fuel and spark timing to our engine. Things like throttle position, if it's not showing 0% when we're off the throttle and tracking our throttle in a linear fashion, going from 0 to 100%, we'll find things like our acceleration enrichment won't work properly, or idle control might not work properly, or the deceleration fuel cut may not work properly. If our map sensor isn't calibrated right, we'll find that when we're trying to dial in our fuel delivery, if we're tuning with MGP or manifold gauge pressure here, which is referencing map pressure and baro together in order to formulate this specific input to the table, we'll find that that's never going to be right. Or if we're referencing something like spark timing and we don't have our map pressure sensor calibrated properly, we may not be delivering the proper spark timing to the engine. Those are really critical things that we have set up properly. Now, looking at our air temperature or engine coolant temperature, it's imperative that these are calibrated properly. Engine coolant temperature, this would be things like our fan turning on and off. And looking at our warm-up enrichment, we need to make sure those are handled properly so we're delivering the proper fueling to the engine when it's warming up or when the fan turns on and off. And the intake air temperature is going to be built into our fueling calculations depending on what type of fuel model that we choose within the Link. It's important that this is properly characterized because as our air temp changes, we need to be able to change our fueling delivery. The density of the air entering the engine changes. So these are very critical sensors that need to be set up properly. And it's very easy to go about getting them calibrated. Let's first take a look at calibrating and working with our TPS and our map pressure sensor. First thing, let's talk about our throttle position sensor. Now we need to go in and make sure we have an area where we can access where we have the specific analog inputs or analog temperature inputs associated to assigning these channels here. We can access that information up here in our ECU settings. If we go here to general log and we go over to the side here, I'm going to go and right click and say new page, and I'll just call this temp, or actually we'll just call this sensors so we can just create a custom page here real quick. Now I'm going to have this page configured here, and what we'll do is go to ECU settings, and we're going to go here down our list under analog inputs. These are analog inputs that we're going to be taking a look at. We're going to go and bring up on our screen here engine coolant temperature. We're going to click on this little wrench icon. This allows us to see where we've configured the input and the calibration scale for engine coolant temperature. We go to our ECU settings. Let's go ahead and grab intake air temp. That's another one we want to take a look at here. Let's bring that little window up in here. And this is our setup and configuration window we need to make sure is right. Let's go back to ECU settings here, and we're going to jump into our map pressure. Make sure our map pressure is configured properly here. And then throttle position, we're going to handle in a slightly different manner. In terms of the calibration, we're not going to do it in a screen like this, but we do need to bring in that throttle position sensor. So if we're looking down here, we see throttle position sensor. So these are our basics that we always want to have up on our screen, and this allows us to access the calibration windows for these specific sensors. So now that we have our windows populated here, we're going to pay attention to our sources, where we actually have our sensors wired into the specific pins. So analog temp 1 is ECT, analog temp 2 is IAT. In my case, analog volt 1 here is MAP, and then analog volt 2 is TPS. Now, if you have a custom wiring application, you're not a plug-and-play application where these are pre-assigned, you have to pay attention to what it shows on your pinout chart to assign these properly. So these are all taken care of for us already. What we're going to focus on here is throttle position. We need to calibrate this. What we want to do here is bring some runtime values into a list. Let's go to digital gauge, and we're going to populate ECT, IAT, MAP, and TPS so we can keep track of those. So if I type in here ECT, let's give this a second. This should populate then our list here for engine coolant temp, and then we'll do IAT for intake air temp, and we'll do map pressure for our map pressure sensor. And then lastly here, TPS, and we'll do TPS main. That's the specific channel we're looking for, and we have those populated here for runtime values. So we can see we can bring them up here, and we can take a look. Let's just open this window up a little bit so they're a little bit bigger and easier to read. And first and foremost, what we're finding here is if I'm off the throttle and it's reading 3%, something's wrong. We need to calibrate this, and that's where we can go in here and set our TPS closed and open positions. Now, we don't have to manually set this up to get our scaling right so it reads a true 0 to 100%. We can go to our TPS calibration in our little wrench icon, and this is going to open up our automatic TPS calibration mode into the link. Right now it's asking me to go all the way full throttle, and we want to do this again, key on engine off so we don't want the engine running. I'm going to go all the way full throttle here, so bring my throttle all the way open. And notice here, I'm all the way open on my throttle, but it's only registering 84%. But that's because my voltage here isn't associated and lined up to my actual sensor movement. So we're going to click OK here. And now it reads 100% at that true 100% reading. Now it's telling me to come off the throttle, so we want to have closed throttle, and we want to bring that back here, and let's get all the way off the throttle here, and it's showing about 4 or 5% or so. So we'll click OK. So that's going to now set our true 0 position. So now it knows 0 and 100. So our throttle position here is calibrated right. That's pretty straightforward. Now we want to perform a store. We'll do Control S that stores the changes. We can see everything in green goes back to gray. That means we've actually sent that as a permanent change to the ECU. Now the map pressure sensor, what we want to do is take a look at what it reads key on engine off. This is 98.2 kPa. Now my barrow pressure should be relatively close to this in the reading. Let's actually just take a look at that. Our barrow pressure is going to be referencing our atmospheric barrow at the elevation that we're at. We want our map sensor key on engine off to essentially match that. If I type in here barrow, we should be able to populate that in our channels list here, and it should be fairly close. Now we have to go through a process here. If I'm typing in, we'll look at our barrow pressure. We go BAP, barrow pressure sensor. And we can see here it's showing 99.3. Map sensor showing 98.2. The calibration scale is set here for a OEM Honda map sensor. If I was changing the calibration scale, I would have to do that. Go double click here and actually select in my drop down menu a different map sensor, whatever type I was using here. So we'd be able to do that. Lots of options in that menu if we have a different map sensor. I have the stock map sensors for right now, so we can see it showing 98.2. That is pretty close to the barrow pressure. We actually have to do a check here. If we go to ECU controls and map sensor calibration, we can click on the icon and find that as well. We'll say, do you want to perform a map sensor calibration? We'll say yes. And what this is going to do is compare our barrow and our map pressure. They have to be within a few kPa of each other, but what we'll find here is that it's calibrated it relative to the barrow pressure. So they should be identical to each other in reading. Again, a small 1, 2, 3% kPa difference is what we use that calibration to clean things up. If you're doing a fresh install, you have to do the map sensor calibration or the engine won't start. Very, very important that you do that. So that's why we're taking care of it right now. So throttle positions calibrated, map sensor calibrated. Engine coolant temperature is going to be that factory sensor. So under the calibration here, I don't need to do anything. But my air temp sensor has been changed here. We've specifically changed it to an AEM Pro Series 8th pipe air temp sensor. So when we're looking here at our IAT, the source is going to be on our analog temp 2. That again is the plug and play location for this box. But moving down here, we're going to find the calibration scales, what needs to be updated. It's not going to be a standard Bosch NTC, which would be compatible with the stock air temp sensor. This is now going to be looking for our AEM Pro air temp sensor. If we're looking down our list here, we're not going to find that as an available option. So that leads us into going in here and using one of these calibration tables. We have our calibration table 1 through 10. This is used for linear or non-linear calibration scales. When we're dealing with a temp sensor, it's a non-linear calibration scale, as we're going to find here. We also have this linear option, linear cal 1, 2, and 3. These are suitable for something like a pressure sensor or a wideband, where they're going to be a linear scale between 2 voltage points. We'll get into how to go and calibrate a linear scale and working with pressure sensors in the next tutorial. This is just, again, focusing on these basics. What we'll do here is select any of our calibration tables in our option through 1 through 10. I'm going to choose my cal table 10 here. I'm going to click OK, and we can see it's going to pop up right here. Now, in order to populate the calibration table, we'll have to jump over here to ECU settings, and we're going to have to go in here into our analog inputs. So we're going to jump into our analog input section here. We're going to move down and we're going to go into our calibration tables. So we can see here is the cal table 1 through 10. Since we've selected here cal 10, we're going to go into our icon here, little wrench icon, bring that up on screen. Let's go ahead and bring this up here and just lock it into place real quick. The label, we're going to change the label name so we know what this is going to be referencing. We'll say AEM Pro IAT sensor. And then the input units, what we're actually going to be inputting from the sensor, so the signal from the sensor, it's either going to be in volts or it's going to be in ohms in this case. Now, we have to reference the manufacturer's data sheet in order to figure out what unit scale they're going to be translating the output from the sensor in, whether it's volts or ohms. Let's go in here to the web browser. I have that PDF sheet from AEM open here. So what we're looking for in our calibration scale is the sensor resistant ohms. So it looks like they're going to be doing this in ohms and not volts. We need to reference that and input this data here into our table so we can populate this correctly. So we're going to choose our input units as ohms. Again, we have to pay attention to the data sheet from the manufacturer. It could be in ohms or volts. The output units, what we want to output. So in this case, we're going to translate ohms into a temperature. We do have these other options, but temperature is going to be what we choose here. Let's click OK. And then the calibration table, this is the last bit we need to go in and work with. So what we're going to do here is do a Control S and store those changes to the ECU. Then we'll go into our calibration table here and we'll double click. If I go ahead and unlock this, double click, now we're left with our table to edit and modify here. Let's lock that real quick. Now we need to go and populate this table. What we're going to find here is that at the top is going to be ohms and at the bottom is going to be the associated ohm to Fahrenheit or Celsius scale. So again, we need to pay attention to our data sheet here real quick. We can see here it's going to reference the ohms to both Fahrenheit and Celsius. So we need to choose which specific scale we're operating on. If we jump back in here to our software, we can check our unit scale. Now we can see it showing here degrees of Fahrenheit if we look very closely at the table here. We can check what specific units we're selected on. If we go here to options, we go here to units, we can see I'm checked on metric. Now you can check on metric or imperial. Imperial standard units would be degrees Fahrenheit or metric would be degrees Celsius. Now in this case, if we go to preferences, I've changed things up a little bit here under units. I've selected metric for things like pressure, distance, lambda, and speed. Under the metric option here, I've changed under temperature from Celsius to Fahrenheit or speed from kilometers per hour to mile per hour. So I've changed that here. The reason why I've kind of made a hybrid setup here if we choose the metric option is because I want to use and work in kPa and in terms of meter and lambda in those values in tune. But when I'm looking at temperature or speed, I want to convert that to mile per hour or degrees Fahrenheit. It's a little bit more familiar for me. Just pay attention to these details. Click OK here. We can see that that is going to be referencing units of Fahrenheit. So what we need to do is go into our data sheet and we need to go and populate this table out. If I click on my axes here, so click on the blue, I click X, that opens up my axes to scale out the table, adding the breakpoints. So what we want to do is take the breakpoints or the populated data here in ohms, so our values here, we want to bring all of this in and create a custom table in our window right here. Let me demonstrate real quick. It's pretty straightforward. Let's take the first data point. We're going to go here, 28,136. So we're going to populate that value right here. We'll click here, 28,136, and we'll click enter. We can see that value here is entered. Let's get rid of our 0 value here. And what we'll find is we're going to populate the next value. So we're going to go click in our open space here and this breakpoint 2. Go back to our data sheet and we're going to enter in our data point here. So 15,813. If we copy this, let's see if it's going to allow us to paste. Not sure if it's going to work. Nope, it's not going to work. So we'll go ahead, we'll do equals, double click here, do equals, and it does allow us to paste right there. Okay, let's move on here. Let's keep going down our list. Let's grab our next point right here. So we'll copy that, move in, we'll do equals, double click, paste, and we'll move to the next data point here. And that's going to be 5,589. So what I'll do here is just quickly run through this. So I'm going to go ahead and just bring all my values here and translate them, and then we'll continue on here in a second once I've completed that. Okay, we can see here, this is going to be the last data point that I can copy and paste from that sheet here. So 73 ohms. We can see we've populated the whole table out. If I click OK and I click yes, it's going to allow me to take a look at this table here. Let's stretch the table out a little bit. So we'll unlock this here. and make sure this is unlocked right here. It should allow us to stretch the table out. Might not. All right, might have to just work with what we have here. If we click H, it gives the table a little bit of color, a little bit easier to see. And normally we can go in here and stretch the table out. There we go. Allows us to now stretch the table out. So we're going to go ahead and try to lengthen the table so it's easier to see. Let's do this one more time here so we can take a look at the table in its whole entire scale. So what we're going to do now is look at the ohm value and then reference our data sheet here, and we're simply going to take the value which would be associated with that, so -4 here at this ohm, and we're going to bring it into our table. So if we double click here, we type in -4, that would be the value there. So I'm going to go ahead and populate this whole table out, and then we'll look at the end result. All right, so here I'm entering in my very last value at the end of the table here, so that's 266 degrees. So now what we're finding here, if we're taking a look at our calibration table, we have a fully populated table here, and we're finding now the intake air temperature and the engine coolant temperature are going to be populated and are going to be calibrated correctly. So what we're finding here, if we're taking a look at our readings in order to reference if our coolant and air temp sensors are reading properly, the engine coolant temperature showing 80 degrees, intake air temperature showing here 77 degrees. So this is going to be with a cold engine. I haven't fired off my engine, so it's key on, engine off. What this is telling me is that this should match or be close to my ambient air temperature. In my heated garage right now, it's approximately 75 to 80 degrees. So as we're seeing here, these are lining up to what I'm measuring with my ambient temperature. We're finding these are very close to each other. 2 to 3 degrees separation is going to be completely normal looking at engine coolant temp and intake air temp readings. So now we've verified populating the correct scale here for the air temp sensor that we've changed out using that linear calibration table. We're verifying that we have air temperature, coolant temperature calibrated, map pressure is correct, throttle position is correct, and everything is ready to go to fire off our engine in terms of our basic sensor input. That's going to be ending here, taking a look at setting up our basic inputs. The next tutorial, we're going to take things a little bit further and take a look at setting up some advanced inputs, a wideband, a pressure sensor, and a rotary trim pod. I'll see you guys now in our next mini training tutorial.